Okay, so thanks for coming, and I was kind of curious how many people would be showing up for something entitled MapReduce using a configuration manager. And I'm not disappointed, because this is definitely a fringe use case. And I'll give a little background on, well, before we get started, let's do what most people do, is they do their own survey here. And I'll ask, just by show of hands, who's coded an app in a MapReduce framework? Okay. And
You want to use your left hand, or shall I hold this for you?
because that's going to be distracting.
Well, it would be, but we've got some audio issues, that's all.
Okay, so we do have one person. Great. And there's no, you won't be thrown out for not raising your hand at any of these. Coded a Salt executable or state module. Okay, great. Coded a Salt runner. Okay. Some more people. Coded a Salt returner. Okay, we have people. Great. I mean, we have all the bases covered, mostly. Okay, run minion as non-root. Okay, in a production environment. Okay, that's. And run minion as both root and non-root in the same container. Okay, and you're fortunate no one rose their hand on that one, because I said I was going to hug a person who actually did that. Anyway, that's something that we do at Verio, and we won't get into the why, but you can do this. It is possible. And you may be here only for this reason, why SaltReduce. And we'll attempt to answer that throughout the talk, but for right now, accept it as a given that you want to do this. And you already know how to use it, so if you aren't using an existing MapReduce framework, then, and it turns out that we do have MapReduce problems if you
Squint.
Yeah, if you squint and look sideways a little bit. I'm going to try and convince you that we do have MapReduce problems, but okay. So before we get to that, I should give a little background as to how this project happened. And it's been 2.5 years ago. I met with Thomas Hatch and discussed some of the weird things that we wanted to do. One was that root and non-root business. But at that time, I also said, you know, I think you could do MapReduce with this, with Salt. And he didn't really endorse that, but he didn't say it was stupid. So, you know, that was the start of the idea. And then later, we had a use case that came up where we were having to do a batch migration, and we're replacing an old existing system. And we needed another scheduler. The scheduling that's done, the default scheduling in Salt wasn't going to work for us. So I sent an email to Thomas and asked, hey, I've got a batch flow, I need a work to do type scheduler. What do you think? And, you know, crickets, which is fine, because, you know, I figured, okay, we're on our own again here. You know, we're doing some weird stuff with Salt. And so I want to assure people, I know that there's a new scheduler out there. So, you know, during this presentation, you're probably going to ask the question, does he know there's a new scheduler? And yes, we know. And then you're going to say, do you know that we already have an example of MapReduce in the core SALT? It's called Survey. And yes, I know because I contributed that code. So anyway, now I'm just going to ask you to go for the ride and accept this, and then later on you can throw your questions out. And okay, so this is MapReduce as most frameworks would have you believe. And basically you take some streams of input, or not streams but batch, and you're going to do some transformation on them. In this case, you're sorting by color. So the first workers here will sort into bins of a particular color, and then they pass on to the next set of workers light colors, and then in the end you've got this merged colors. So this is classic MapReduce, and I'm talking about MapReduce as Google defined it, because they pretty much defined the industry, and in Hadoop and most things derive from them, although there's other ways of getting here. So the other thing I want to mention is that we realize that there's lots of ways in SALT to do this, and I'm not necessarily saying this is the best way, but it's a way, and it does have some advantages. Okay, and I'll start out with the non-goals because I want to establish right off the bat that we are not trying to supplant. This is, right now this is just a lab animal, and it's encouraging, but it's got wobbly legs, and I'm not going to say that this isn't even an intention of ours, so nobody get upset, please. So our project goals were to leverage the existing SaltStack framework. And we want minimal code for a hello world. So a hello world SaltReduce app, and keep it salty. Yeah, and an argument can be made that that we've been too salty in this implementation, and I'm going to make that argument in a few places, and I'll show you where. Okay, so demo. Before we do the actual demo, though, we should, by way of an animation, we should describe what's going to happen. Otherwise, the demo is just going to be a bunch of output flying by. And so, in fact, this slide probably took more work than writing the code for this. So that. So we're all familiar with SaltMaster running with a bunch of minions talking over an event bus. And in this case, it's 0MQ, but that's the default, but you could use whatever one you chose. Okay, so what just happened? We invoked a salt runner, and people are making fun of my lack of imagination for names here, because but it's easy for me to remember, just rerun. So at this point, we've launched a runner sitting on the SaltMaster, or we'll say not in, but adjacent to. And it's sitting there listening on the event bus for events tagged with rerun. So right now it has no jobs, it has no, it's just waiting to be told what MapReduce to run. Okay, Now this is the way the runner gets told what MapReduce job is going to be installed on it. And so we'll get into this a little bit later, but I'm overloading this test.arg. So this is a way, this may be the too salty part. This is my API dispatcher. I didn't have to write a bunch of code for this, so I'm just repurposing test.arg to just pass all these arguments on the event bus so that this runner can do the right thing. So what the runner did is it peeked inside of this adder salt module, and it looks to salt like it's a salt executable module, adder.add. But the runner will look inside and say, is there a mapper and a reducer in here? And if there is, it'll install it. And if there's a regular salt module and there's not one that exists, it has a default. So you can actually run MapReduce jobs on existing salt modules. You don't have to have a custom one to do this. But so this is our hello world, adder.add. And in this example, what are we're running, what, 10 million? In the demo, we're going to do 2 billion, but this was an early slide. Okay. Now we're still using our test.arg, and we're using this returner. That all it does is, so if you've written a returner, you're used to talking to a database or something in the back end. Well, our returner actually sends the results back to the runner. So we're kind of eating our own exhaust here in a way. And so this is how you prime the pump and get it started. And so if you let this go, that runner would plow through the jobs or the sharded workload until it was done. And wait for it. Okay. So the results got reduced on the reducer, and now this mapper will invoke another adder module with the proper partial result. So it's actually, it did the sharding of whatever you specified here into partial adds. So this is one of those embarrassingly parallel problems. You know, what we're doing is we're adding up a sequence of 1 million numbers, like so 1 plus 2 plus 3, and so you can parallelize that real easily just by, I'm going to add up the first 100,000, and then I'm going to add up the second 100,000, then I'm going to add all those things together. So that's our hello world. But that's taking too long, so we run this again, and we have 2 running, and now they're both accepting work from this mapper. And again, we want to apply more minions to this, so we cut them all loose and we put 3 at a time on here. Okay, now these things will cycle through until they complete, and then you get, the runner will report the results. So I hope that made sense. Okay, now back to our graph. Oh, we should do the actual demo now before we forget what that slide told us. Okay, and all this code is going to be available in a repo when we done here. So I'm running in 2 windows here, but the one is just to show you the salt processes that are running and getting invoked. So here I've fired up this rerun runner in verbose mode, because if we don't, it's going to be really boring instead of just slightly boring. Okay, so now we've done the salt call, and we are saying do 2 billion. But still, there's no minions that have been assigned to doing this task yet. So now we have 1 minion doing the job. And these things take usually about 6 seconds. This time it was 4 seconds. But let's add another one to the job. And you're seeing over here in this screen multiple minions on the same machine. And some people don't realize that you can run minions simultaneously. And so for purposes of this demo and my single laptop, it makes sense to just, and I've got 2 cores, so we're going to see how this, let's throw a few more of these guys on. So I can add more minions at any time, and it just makes it better as long as you have more cores. And so now we have 3 minions. And you'll see that the master is hardly even taxed, which is where the runner is running. And with 20, we should be done, but now we have to wait for all those jobs that were in flight to finish. Okay, so here's our stats. And that took 61 seconds of runner time on the master, and it took 114 seconds of, if you added up all the work done on all the minions. So this is a definite win. And it's about twice as fast. So that's what we'd expect with 2 process. And I've got an underpowered laptop here, but it's kind of like the car I drive. Okay, now just to, and wait, there's more. This minion, or this salt executable module, so it'll run as a salt reduce module, but it'll also run as a standard salt module also. And I gave it this name, but I keep forgetting what it was.
Somnums.
Thank you. And so, same module adder, but this is another, this is something to validate that I actually get the right results. So if I wanted to, what have I got there, 1 million, add up 1 million, yeah. And that's the answer for, we won't go and wait for that to complete, because it actually takes longer than, it's faster than the combined of sharding all the work, but it is definitely slower than our salt reduce example. So anyway, that showed that we can run as a normal salt module. Okay, so now we want to run a normal salt module as a salt reduce. And here's a really non-interesting, you can guess what this one does. So now our job is to sleep, and but it is, so now we're going to run 40 times 15 seconds, so 10 minutes of sleep, but we're going to run that on multiple minions, so it shouldn't take 10 minutes. And So now it's firing up all the workers. And we'll see how quickly we can get. And you're not seeing anything in here because there's no CPU associated with it. But you're seeing here, this is actually scrolling by. And now we're seeing the in-flights completing, but the last sleep has not slept. And wait for it. There we go. So we did 10 minutes worth of sleep in 38 seconds. So that's really just to validate that this works. Okay, was that it for the demos?
Yes. Onto the slide. Oh, we forgot to mention this bit, the job IDs.
Oh, yeah. So, and the reason we can get by with running all these on, even though this thing makes you think that you're running these on multiple minions, our demo ran it on basically the same minion. The reason we can get away with that is that our job scheduler keeps track of them by job ID, so that way when they come back we know who to reschedule on. Okay, so here's back to the graph. We already went through that, but now we're going to show you what we really did, because we're not totally faithful to the Google implementation. So we dropped out one layer here, so there's not as many tiers. Sorters map to minions. Reducer maps to this rerunner. And this is also, so anyway, look at the containers there and you get a feel for how we mapped our stuff onto Salt. Okay. Here's the location for, and here's the code layout. So what we did here is just break up the modules that went into doing this demo. And these first three are framework, so presumably you won't have to write that each time. There does need to be some work on here, and I don't want to say that do not take this into production, please, because it's, like I say, it's got wobbly legs, but I think this kind of proves out that you can do MapReduce style problems. So the only thing that we had to write for the hello world was 94 lines of code, and I think it's actually 90 now. Okay. And here's where we show that part of that code that we've got in the module actually runs in the runner. And so you have to do some, hackery here to get Salt to ignore that stuff in the header that's going to, because Salt modules don't know about this MapReduce thing. And, but you can fake it out. So it's part of the payload, but it gets ignored when it's a Salt module. And it just gets imported into the runner. Okay, some open issues. And we talked about, how are we for time?
We've got 20 minutes.
Oh.
Well, we should probably only talk for 10 to 15. We got 10, yeah, we're good.
Okay, so yes, replace the test.arg hack with something more suitable. And one of the reasons we need to do this is that Salt does the right thing when you specify the same minion multiple times on the command line. It says, hey, I'm not going to do that. So if you put minion 1 5 times on the command line like I want to do, it says, no, you mean once. And so it reduces that down, which is typically what you want to have happen. If you're running a salt state, you don't want to run that 5 times on the same command line, typically the same. So, but for purposes of MapReduce, we want to run as many as you have processors, or as much as that machine can handle. So there's a reason for your own version of test.org. Right now, there's not multi-rerunner support, and this is due to the fact that I'm using this custom returner. We share the same namespace with tags, our event tags, so that if we ran another rerunner, it's going to want to use rerun as the tag. And so the only way to divide up that namespace is to pass some kind of argument into the returner. But right now, returner doesn't know how to handle that. So one solution is just to collapse the returner into the salt module itself, and that could be done. You might want a single load and go command. So that, and I subscribe to the Linus Torvald model of APIs where you have porcelain and plumbing. So you pretty much saw plumbing there. It may not be the thing that you want to interact with. When you flush the toilet, you want to just push one handle. You don't want to have to turn the water on. And so anyway, that's a criticism, and I'll own that one. More better stats. Oh, and I should have mentioned earlier, in the demo, we were getting back those results from the minion. But that ends up being a MapReduce problem also. I mean, adding up all the time spent on all the minions, it's just like adding up. So it's the same thing, except that the framework does that for you. So it's not something that you have to do. We always like it as programmers when something like that happens. Oh yes, load limiting mapper. So there's the potential for, because you get the results piggybacked, the timing results piggybacked on the normal results, you can know what load is on that machine. So right now we're giving back the amount of time that the minion spent in user, system, in real. If you piggybacked on load average, you could choose to not schedule a job on that minion or not. So you have the ability to be a good citizen, you know. So if you're sharing your cluster with some other activity, anyway, you have that ability. That's not in there now, but that I can see easily adding that code. And then the rest of these, pretty much self-explanatory.
So, well, right, so what we've done at this point, we've shown not just MapReduce, but in general, a batch scheduling system, right? Where you have a number of jobs that you want to process, and you go through, process them, distributing the work as necessary. So it's much more general than just solving MapReduce problems. And with that generality, we've got a question. This.
Okay, so I didn't complete the background is that of the motivation for this thing. And it wasn't exactly a bet, but we'd already produced something similar to this to do batch scheduling on our own. And David, in fact, he's in his last month. He'll be graduating here in a few days. So I'm glad I could even get some time on his part, but because he's been really distracted with this thing called graduating. I don't understand it. But he had a problem in his bioinformatics class that required MapReduce. And I thought, you know, he's written this stuff up in Python, and now he has the problem of, okay, let's make it MapReduce. And I thought, you know, we should be able to take our batch scheduler and do MapReduce. The only difference is that in a batch scheduler, the work comes pre-sharded. In a MapReduce problem, well, we have to shard it up and then run the stuff. And if you look in Wikipedia, not that it's the last word on anything, under MapReduce, at the very end, they actually talk about, yes, and it uses the same scheduling pattern that MapReduce does, so batching. And so this is the issue, and I think a lot of people encounter this. They'll be in a design of a new system, or they're replacing an old system. In our case, it's a migration system, and we have a cluster of staging servers that migrate from multiple sources to multiple targets. And we're talking about thousands of these machines that have to be migrated. Customer accounts have to be migrated. And these are done in a batch mode. And everybody's on board with, oh yeah, well, we'll use Salt to set up our staging servers to do this, to do our custom migration servers. But what keeps Salt from doing that? And so you end up re-architecting a lot of these same ideas, and these same patterns show up. And it turns out that this is my hypothesis of why, and we can't say, I mean, there's reasons for all these other clusters in the data center, and I'm not going to say that all of them should be replaced by a configuration manager. I'm not making that claim. But there's a lot of things that we're doing in the area of orchestration and, in our case, batching, that come down to, I think, scheduling patterns. So I'm going to just, there's many more scheduling patterns than just these two, but I'm going to make this distinction. On the left here, we have what configuration managers are good at in general. And these are targeted, one and done types of things. Now, yes, SaltStack has added a scheduler, but it tends to be more like a cron job. And the machine, or the system that we're replacing was a cron-based system, but it has issues when you do that with, and we don't have time to get into that now, but talk to me later and I'll give you my rant on polling in the data center, okay? But just let me go on the record. Polling is not good. And then the thundering herd problem, which shows up too, and you'll see all kinds of games being played to avoid thundering herd when you go to a polled system, and our old system, suffered from that also. So in a new system, you don't have to do polling, and this is where tasks do not equal the number of workers. So, and this is probably our most controversial slide. Should we just open it up to questions here? Yeah, we should. So, or did you have something to say before?
So, I don't know how clear, how do you all feel about this slide? Is it clear, unclear?
Actually, so prior to starting at SaltStack, I worked with adaptive computing. We did the queue-based schedule on the right side. So
okay.
I personally understand this whole problem set from high-performance computing.
Yes.
Queue and all of that.
Okay.
Versus what we have, and there's actually some models we've been playing around with the runners to actually mimic the queue.
Okay, and that's what.
We'll talk to you a little later after that, but this makes total sense.
Okay, and it's good that you've identified that, because I think this is at the core of why people aren't doing, and I'm not sure, but I think Kubernetes, and some of these things are a result of scheduling patterns, and so that was MapReduce. I hope you're not disappointed, but and we could have shown, you know, David doing bioinformatics, but doing that over wireless, and we'd still be waiting for the result to come in, and you wouldn't have learned what we wanted to show here. So, and I think we can get out early if there's no questions. But
Yeah.
is that allowed? Okay, we gotta. Yeah, because you're that close. Okay, and in a former life, I spent a lot of time in operating system scheduler, so yes, that's been my, but a lot of people don't understand this, so that's the frustration.
In fact, we've actually hired a couple other engineers from adaptive teams.
Okay, well, good.
Leadership.
Yeah, a very important distinction, because when I've tried to, so anyway, that's why this conference was good to present at, because it requires more than 2 emails. Okay,